Boston Dynamics' new creation, the Atlas robot, blurs the line between machine and man because it doesn't just walk or jump, but moves in a scary human-like way. This robot feels nothing like mere code when it performs backflips or balletic balance. But as we marvel at its capabilities, a chilling question arises. Are we witnessing the birth of truly sentient machines? Could we be engineering our own end? Join us as we dive into the astonishing capabilities of Boston Dynamics' new Atlas robot and explore why its realism is both a technological triumph and a terrifying wake-up call. The creation of Atlas. The Atlas is a machine, a robot, rising from the earth like it's possessed, contorting its limbs in manners no human could, before spinning its head 360 degrees to look at you with a glowing, all-knowing eye. While this may sound like something from a sci-fi movie, it's not a sci-fi movie, but Boston Dynamics' latest version of its humanoid robot, Atlas. And the internet is divided between being impressed or scared. Unveiled on April 17th in a YouTube video that has already elicited a mix of awe and unease, the new Atlas begins its debut face down on the floor like a prone corpse. But in seconds, it leaps to life, bending its legs backwards in ways no human could, employing its newly created fully electric rotatable hip joints to stand upright. And then, as if it has not already gone far enough to call up the uncanny valley response, it slowly rotates its cylindrical head in a full circle, staring directly into the camera. But that is not all. Yes, this thing woke up like it knew it was being watched. Boston Dynamics has long been at the forefront of robotics, with past Atlas models doing parkour, lifting heavy equipment, and dancing to pop music. But this new version? It feels less like a lab experiment and more like the early stages of a sci-fi uprising. Unlike its bulky hydraulic predecessor, which the company has now officially retired, this version is leaner, electric, and far more unsettling in its lifelike motion. With Spot, with Stretch, and now with Atlas, the company says, we're solving the toughest challenges in the industry. Which sounds great, until you remember that this robot just did a head spin straight out of the Exorcist movie. Sure, Boston Dynamics wants to pitch this as a helpful machine for factory work and logistics. But many viewers are asking, how long before this thing trades its warehouse tasks for something less helpful? The humanoid robotics space is witnessing a surge of innovation, with major players like Tesla, Figure AI, and Unitree Robotics unveiling advanced models that push the boundaries of technology. Tesla's Optimus Gen 2, for instance, showcases enhanced motion capabilities and improved hand dexterity, enabling it to perform tasks such as folding laundry and even dancing. Similarly, Figure AI's Figure 02 robot boasts advanced AI, improved dexterity, and longer battery life, making it suitable for industrial applications. Unitree's H1 robot, on the other hand, is designed for agility and speed, capable of running at 3.3 meters per second and navigating complex terrains autonomously. Despite these advancements, Boston Dynamics' new Atlas robot stands out due to its captivating human-like movements and behaviors. Unlike its counterparts, Atlas exhibits a fluidity and range of motion that closely mimic human anatomy, including the ability to rotate its head 360 degrees and perform complex maneuvers with ease. This level of realism blurs the line between machine and human, evoking both fascination and unease. While the full extent of Atlas's capabilities remains to be seen, Boston Dynamics has hinted at future demonstrations that will showcase its potential in various real-world applications. As we stand on the cusp of a new era in robotics, the question arises, are we prepared for machines that not only perform human tasks, but also move and behave like us? While you think about these questions, it will surprise you to realize how much the robots already seem to be taking over. Let's take a look. Humanoid robots are taking over. Humanoid robots have moved from prototype designs to practical tools, impacting several industries by performing tasks that are dangerous, repetitive, or require human-like interaction. An example is the Atlas robot developed by Boston Dynamics. Originally designed for research purposes, Atlas has demonstrated considerable agility and dexterity, such as navigating challenging terrain and manipulating objects in simulated construction settings. In a future demonstration, Atlas retrieved tools for a laborer on a scaffold by lifting a plank and building a bridge, then delivering a precise throw, demonstrating its use for application in risky scenarios where human safety is a concern. In manufacturing and logistics, humanoid robots are addressing labor shortages and enhancing efficiency. Agility Robotics Digit, a bipedal robot, is actively employed in GXO Logistics Spanx factories, autonomously moving boxes onto conveyor belts. This deployment illustrates how robots can perform physically demanding tasks, reducing human workload and injury risk. Similarly, Boston Dynamics plans to introduce its all-electric Atlas robot into Hyundai factories, marking a significant step toward integrating humanoid robots into commercial manufacturing processes. Healthcare is another domain where humanoid robots are making strides. The Unitree G1 humanoid robot, for instance, has been utilized in teleoperated medical procedures, including physical examinations and precision tasks like needle insertions. This application demonstrates the robot's potential to assist in medical interventions, especially in situations requiring isolation or in areas with limited medical personnel. Additionally, therapeutic robots like Paro, designed to resemble baby harp seals, have been effective in calming patients in hospitals and nursing homes, providing companionship and emotional support to individuals with dementia or autism. It gets even more fascinating. In the area of education, humanoid robots are serving as innovative teaching aids. Robot Shalu, developed in India, is capable of teaching multiple subjects in 47 languages and is currently employed in classrooms, enhancing the learning experience and demonstrating the versatility of humanoid robots in educational settings. Public safety has also benefited from humanoid robotics. In the Democratic Republic of Congo, engineer Thérèse Kirongozi developed traffic robots equipped with cameras and sensors to manage traffic flow and enforce regulations in Kinshasa and Lubumbashi. These robots have improved traffic management and reduced accidents, showcasing how humanoid robots can contribute to urban safety. Although they at times look strangely like humans, which can be disconcerting, humanoid robots are turning out to be invaluable resources in most sectors. Their ability to perform complex tasks, adapt to varied environments, and interact with humans makes them invaluable resources in addressing contemporary challenges in industry, healthcare, education, and public safety. Boston Dynamics has been an industry leader in robotics for decades and is known for making highly mobile and dynamic robots. It was founded in 1992 as a spin-off from the Massachusetts Institute of Technology and originally focused on simulation software before transitioning to physical robots. Over the years, Boston Dynamics has introduced a series of innovative robots, including Big Dog, Spot, and Atlas, each pushing the boundaries of robotic mobility and functionality. One of the company's earliest breakthroughs was Big Dog, a quadruped robot developed in 2005 with funding from DARPA. Designed to navigate rough terrains, Big Dog demonstrated remarkable stability and agility. Following Big Dog, Boston Dynamics developed other robots such as Cheetah, which set speed records for legged robots, and LS-3, a militarized version of Big Dog intended to carry equipment for soldiers. These robots showcased the company's commitment to creating machines capable of operating in challenging environments. In 2013, Boston Dynamics unveiled Atlas, a bipedal humanoid robot designed for a variety of tasks, including search and rescue operations. Atlas demonstrated impressive capabilities, such as walking on uneven terrain, performing backflips, and executing complex parkour routines. The robot's development marked a significant milestone in humanoid robotics, highlighting the potential for machines to perform tasks traditionally carried out by humans. Beyond Atlas, Boston Dynamics has continued to innovate with robots like Spot and Handle. Spot is a quadruped robot resembling a dog and has been deployed in various industries for tasks such as inspection and data collection. Handle, which is designed for material handling, combines wheels and legs to move packages in warehouses efficiently. These robots show the company's focus on developing practical solutions for real-world applications. Today, under the ownership of Hyundai Motor Company, Boston Dynamics continues to lead in robotics innovation. The company's latest developments aim to integrate advanced mobility, dexterity, and intelligence into robots capable of operating in diverse environments. As Boston Dynamics advances its technology, it remains at the forefront of directing the future of robotics. But why is it hard to access Atlas? The answer will amaze you. Atlas is off the table. If you've ever dreamed of having your humanoid robot, perhaps one that can do backflips, jog upstairs, or just terrify your neighbors with a strange 360-degree head spin, Boston Dynamics Atlas is likely to top of your wish list. But before you get too excited, there's a catch. Atlas isn't for sale. Boston Dynamics has made it clear that this robot is a research and development platform, not a commercial product. It's not something you can buy off the shelf or even pre-order for your tech startup. Instead, Atlas serves as a high-performance testbed for cutting-edge robotics research, pushing the limits of what machines can do. That doesn't mean it's priceless, just that the price is out of reach for the average person. Industry insiders estimate the cost of one Atlas unit to be well into six figures, likely exceeding $100,000. And that's probably a conservative guess when you factor in the custom hardware, proprietary software, and the intensive development behind each unit. Atlas is built to demonstrate what's possible, not what's affordable. It's featured in flashy showcases of parkour routines, ballet-like motion sequences, and complex obstacle navigation, not warehouse jobs or home assistance duties. Because of its status as an elite R&D tool, Atlas typically ends up in the hands of large institutions, such as government-backed research labs, elite universities, or tech companies with major robotics budgets. These high-budget projects use Atlas to study balance, motion, and control in humanoid robots, paving the way for future machines that could one day be mass-produced. But for now, unless you have deep institutional funding, or you're a Fortune 500 company exploring next-gen automation, owning an Atlas is off the table. If you're intrigued by Boston Dynamics Atlas, but find its exclusivity and estimated six-figure price tag daunting, there are more accessible alternatives in the humanoid robotics market. Companies like Unitree Robotics and Engine AI have introduced models that, while not matching Atlas's capabilities, offer impressive features at more attainable prices. The Unitree G1 is a compact humanoid robot designed for research and development purposes. Standing at approximately 4 feet 3 inches and weighing around 77 pounds, the G1 is equipped with advanced mobility features, including the ability to climb stairs and navigate obstacles. It comes in different configurations. The base model with 3-fingered hands is priced at approximately $16,000, while the version with 5-fingered articulated hands costs around $21,000. It doesn't end here. These robots are available for purchase through Unitree's official channels and authorized distributors. Engine AI, a Chinese robotics company, offers the PM01, a lightweight and dynamic humanoid robot. Standing at 1.38 meters and weighing about 40 kilograms, the PM01 features 24 degrees of freedom and a 320-degree rotating waist, enabling naturalistic movements. It is powered by Intel N97 and NVIDIA Jetson Orin processors and includes an interactive core screen for seamless interaction. As of early 2025, the PM01 is priced at approximately $13,700, with both commercial and educational versions available at this unified price, until March 31st, 2025. Interested buyers can purchase the PM01 through Engine AI's official website and authorized resellers. While these robots are more affordable than high-end models like Atlas, potential buyers should consider factors such as intended use, support, and integration capabilities. The Unitree G1 and Engine AI's PM01 are primarily designed for research, education, and development purposes. They offer a platform for exploring humanoid robotics without the substantial investment required for more advanced models. While owning a robot like Atlas may be out of reach for most, companies like Unitree and Engine AI are making strides in providing more accessible humanoid robots. These alternatives offer a balance between functionality and affordability, opening opportunities for enthusiasts, researchers, and small businesses to engage with humanoid robotics. While Boston Dynamics Atlas remains a pinnacle of humanoid robotics, several other models from global competitors are making significant strides in the field. Notably, companies from China and Russia have introduced innovative humanoid robots that are gaining attention for their capabilities and applications. Engine AI, a Chinese robotics firm, has developed the SE01, a full-size general-purpose humanoid robot. Standing at 1.7 meters tall and weighing 55 kilograms, the SE01 boasts 32 degrees of freedom and can walk at speeds up to 2 meters per second. It is capable of performing actions such as squatting, grasping, running, and jumping. The robot utilizes an end-to-end artificial neural network to optimize its gait performance, enabling it to take large strides, which is particularly challenging for bipedal robots. The SE01 is available for global sale in both commercial and educational versions. Both versions are priced at 88,000 yuan, which is approximately $12,000 until March 31st, 2025. FEDOR, which stands for Final Experimental Demonstration Object Research, also known as Skybot F850, is a Russian humanoid robot developed by Android Technics. Originally intended for rescue operations, FEDOR was sent on an experimental mission to the International Space Station in 2019. The robot replicates the movements of a remote operator and can perform some actions autonomously. Standing at 182 centimeters and weighing 106 kilograms, FEDOR operates on a real-time Linux-based operating system and can walk at speeds up to 4 kilometers per hour. Its development showcases Russia's commitment to integrating humanoid robots into space exploration and other advanced applications. Agibot, another Chinese robotics company, has introduced the RAISE-1, a humanoid robot aimed at industrial applications. Standing at 1.75 meters and weighing 53 kilograms, the RAISE. A1 possesses 49 degrees of freedom and can walk at speeds up to 7 kilometers per hour. It is equipped with RGBD cameras, LiDAR sensors, and modular components, enabling it to perform tasks such as bolt tightening, vehicle inspections, and laboratory experiments. Agibot's focus on mass production and open-source development positions the RAISE-A1 as a significant player in the industrial robotics sector. These developments highlight the global race in humanoid robotics, with companies from China and Russia making notable advancements. As these robots become more accessible and versatile, they are poised to play increasingly prominent roles in various sectors, from industrial applications to space exploration. Owning a humanoid robot like Boston Dynamics Atlas isn't as simple as buying a gadget off the shelf. Although Atlas is at present a research and development system and not available for commercial sale, the overall implications of ownership of humanoid robots are considerable. As robots increase in autonomy, they raise challenging legal issues, most notably in relation to liability. Let's take a closer look. Safety and privacy concerns. Humanoid robots are safety-first designed with multiple systems to prevent harm to human beings. Mitsubishi's Wakamaru robot, for instance, designed for domestic use, employs ultrasonic and infrared sensors to perceive and steer clear of objects like people. There are also manual stop switches on its body, which allow for immediate shutdown in case of need. Detailed risk analyses have proven that Wakamaru's wheels and arms are not sources of injury risk in the event of collisions. Similarly, Baxter, an industrial robot by Rethink Robotics, has sensors on its hands and arms to sense and respond to the surroundings. This ensures that Baxter can sense impending collisions ahead of time as well as reduce the force before impact, thus rendering Baxter safe for human collaboration. Despite all these safety measures, there have been incidents involving accidents where human beings have been hurt by robots. In 1979, Ford Flat Rock factory worker Robert Williams lost his life when he was struck by a robot arm due to a lack of adequate safety measures. Similarly, in 1981, Japanese maintenance engineer Kenji Urata was killed after he got pinned by a robot against a machine when he bypassed safety barriers. More recently, in 2015, Wanda Holbrook was fatally injured when a robot at a factory in Michigan suddenly activated. Such incidents highlight the need for adequate safety measures and human intervention in the working places where humans and robots collaborate intensively. In the United States, manufacturers are typically held accountable for defects in design, manufacturing, or inadequate warnings under product liability laws. However, as robots like Atlas become more autonomous, determining liability becomes more complex. If a robot's machine learning capabilities lead it to act beyond its original programming, it may be challenging to hold the manufacturer liable for unforeseen actions. This is because the robot's behavior could evolve post-sale, making it difficult to attribute fault directly to the manufacturer. Owners or operators of humanoid robots may bear responsibility for the robot's actions, especially if negligence in operation or maintenance leads to harm. As robots become more autonomous, the legal systems might change to make users responsible for accidents or problems caused by the robot's actions. This development recognizes that even though robots are autonomous, human operators remain in charge of directing and controlling their actions. The use of sophisticated robots poses privacy and surveillance issues. For instance, Boston Dynamics promotes the prohibition of weaponizing robots in legislation, illustrating the need for regulations as a countermeasure to potential abuse. As robots expand their presence in public and private spaces, protection against their encroaching on citizens' privacy rights is crucial. This includes issues of information collection, surveillance capabilities, and potential abuse in various environments. Do you think these robots might have a glitch and harm us one day? Where do you think we should draw the line in robotics innovation? Let us know in the comment section. We hope you enjoyed watching this video. Remember to like, share it, and subscribe for more. Also, click the next video showing on your screen. You will enjoy it.